So looking at these problems, and again, I picked these problems specifically because they were things that were on your test but were not covered on your test review. And so, like, to answer the question, will this be on the test? Absolutely yes. Okay, these are things that I handpicked because they were on the test. So first one, this is that new stuff that we learned on Friday, I don't remember, I think Friday. We talked about the graphs of the sine and the cosine function, okay? And most of this stuff is in your notes, so I don't know if I have to go through the whole thing, but I do want to kind of talk through the process of sketching one of these graphs so that you could recreate it on your own if you had to. In your notes, we did the sine function together, and then you did the cosine function on your own, so I think I'm going to graph the cosine function, okay? And then the sine function is really similar. So I'm graphing cosine of x. When I draw my graph, what goes along the x-axis? Like, how am I numbering my x-axis? Say it again, Ethan? Not sure. Connor, go ahead. Okay, so I number it, it's my angles, right? Because this x, this is going to be angle measures of some kind. And yes, in your notes, we numbered it in radians. On your test, though, the angles are numbered in degrees. So I'm going to do this one with degrees. It's going to work exactly the same way. Degrees, radians, it shouldn't matter. But I'm going to number in degrees. Okay, so this will be my axis here. And I'm just going to go, this is 90. By the way, on your test, the graph is numbered for you. So you don't have to worry about creating this part. But and then I'm going to go backwards a couple. We'll go negative 90, negative 180. How should I number my y-axis? How high and how low does my y-axis need to go? Go ahead, Connor. Yeah, really I only need one in each direction, right? I need a positive one and I need a negative one. We know the numbers really keep going, but our sines and cosines are never bigger or smaller than 1 or negative 1. So to do this, and you can do this like on your test if you're having to draw one of these graphs, make yourself a unit circle, okay? Or maybe you use the unit circle that you already have for other questions on the test. And as far as drawing the graph goes, we can draw the whole graph using only these 4 coordinates, okay? Because those are going to be kind of your boundary points. So I'm just going to write these in. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And I'm graphing cosine right now. So if I'm graphing cosine, what part of this do I want to pay attention to? Yeah, I'm looking at these numbers right now because I'm looking at the cosines, and the cosines are always the x-coordinate or the first number in that coordinate, okay? So at 0 degrees, which is this spot on my graph, at 0 degrees, my cosine is equal to 1, so I'm putting a dot at 1. At 90 degrees, my cosine is 0, so I'm putting a dot at 0. At 180 degrees, my cosine is negative 1. At 270, my cosine is back to 0. And when I go all the way around to 360, that should be in exactly the same spot that I started, right? So that's going to be back up here at 1. What if I went backwards to negative 90? Yeah. So negative 90 would be here, right? It's going backwards 90 degrees, so that's 0. What about negative 180? Yeah, negative 180 is actually the same as positive 180, right? So that would be a negative 1 here. And resist the urge to make your graph look like sharp and pointy. It is supposed to have sort of a curve to it. So I'm going to do something that looks like this. Whoops, I missed that dot, but get the idea. Connor, go ahead. We are. I just hadn't decided as of Friday what we were doing yet. So I have. Thank you for that. I've made a different decision, unfortunately, but I just haven't had a chance to fill in those days yet. Okay, so that's what our graph looks like. The sine function, if I asked you to graph the sine function, would work exactly the same way. except you'd be taking these numbers off your unit circle, right? So you would start at 0, and then you would go up to 1, and then you would come back down to 0, and then -1, and then back to 0. So it's going to look exactly like this. It's just shifted over slightly. Okay? What's the domain of this guy? All real numbers. Yep. Because this thing goes on forever. It doesn't. There's no gaps along the x-axis. What about the range? Yep. So we want to just say it's everything between -1 and 1, which is what that notation is saying. And then the new word that we learned in relation to these graphs is the period. Remember, the period is how long does it take to complete one full cycle? Okay. How long does that take on this graph? Yeah, so we said, I think before, we called it 2 pi because we were talking in radians, but if we're talking in degrees, we would say that our period is 360. And actually, all three of those things are exactly the same when we go look at the sine graph as well. Okay? Questions on that? Do you feel like you need to see me graph the sine function? Are we good? Okay. All right, so let's look at this number 2. And for number 2, I'm going to throw a note in here that if you wanted to see a worked out example of this, I mean, I'm about to do one, but if you wanted to see another one, in your 10-3 notes, and then I think it's in example number 2, okay, we did one exactly like this. So we're looking at cosine theta, and we have cosine theta, and we're trying to find sine of that same angle, okay? Now, some of you did this a slightly different way, and there's a tiny flaw in the reasoning, but I think you could still make it work. I'll show you that after I'm done with sort of the official way to do this. But mathematically, the best way to do this is using the trig identity, or the Pythagorean identity, I guess I should say. So that's cosine theta squared plus sine theta squared equals 1. Do you remember that formula? Okay, so that was from one of our formulas we learned in 10-3, and the reason we like this is talking about cosine and sine of the same angle. It's the only formula we have that relates the cosine directly to the sine, okay? So I'm going to take this cosine value, this 0.37, and just plug it in here. So I'm going to go 0.37 squared plus sine squared equals 1. And let's see, 0.37 squared gives me 0.1369 plus sine theta squared equals 1. What now? I'm trying to get this sine theta, right? That's what I'm trying to figure out. So I'm going to do 1 minus the 0.1369. And so now I have sine theta squared equals 0.8631. What now? Square root. Good. Okay, so I'm going to square root. And I end up with sine theta equals, let's see, 0.929. Now, I took a square root, though, so what should I be remembering right now? Yeah, I need a plus or minus, and I'm going to draw you a picture here in a second to show you why I need that plus or minus. But notice it says find 2 possible values. The plus or minus takes care of those 2 possible values, okay? So both of those answers are correct. If we know that the cosine of some angle is 0.37, your sine could be plus or minus 0.929, okay? So here's the thing. Here's why this plus or minus shows up. Let's see. Actually, maybe I'll just draw it on the board. This plus or minus shows up because if I know that my cosine is 0.37, okay, my cosine is my x-coordinate. So if I go to like 0.37 here along my x-axis, there's 2 places where this is true. There's this place and there's this place, okay? those are both going to start, like if I look at coordinates, it's going to be 0.37 and then whatever the sign is. And this point down here would be 0.37 and then a negative of whatever that sign is. That's why you need the plus or minus, because when I tell you this information, when I tell you cosine theta is 0.37, you don't know if you're standing here or here. Okay, it could be either one of these, and that's why you can find this number. This number is that 0.929, but if I'm standing up here, it's positive. If I'm standing down here, it's negative. Okay, Connor? Is it possible to figure out exactly which point you're at? Not based on what's given there. I would have to give you some other piece of information, like if I gave you an interval, if I said the angle is between like 0 and pi over 2, you know, or if I gave you some other, like if I told you what the tangent was, if the tangent's positive, you must be living here. If your tangent's negative, you must be living here. I would have to give you something else. But yeah, based on that, it could be either one of these. Okay? Now, some of you took a different approach to this, and your approach is not wrong. It's just there's one tiny flaw in your reasoning. Did anybody jump into this by doing an inverse cosine? Did anybody do like inverse cosine of 0.37, and I think you get like 68.3, something like that. What is that you found? It's the angle, so it's the theta, right? If you did this, if you did inverse cosine, you found what theta is, which is fine, okay? And then the question is, what is sine of theta? So then you could say, oh, well, I can find sine of theta by just doing sine of 68.3, and that should give you that 0.929 number. Okay? It doesn't give you both. And the reason for that is when I do this inverse cosine of 0.37, this is me asking the calculator, hey, what angle has this cosine? Your calculator only gives you one of the two answers. Okay? There's two possibilities here. Your calculator only gives you half the story. Okay? And so this 68.3, that's this angle. So you know that this is 68.3, but there's another angle that could have a cosine of 0.37. So if you want to go this route, that's okay, but you have to know at the end that it's not going to spit out the plus or minus for you. You have to remember to add that on there. Okay? There's a way you could figure out what this theta was. You would basically do like 360 minus that 68.3, and you could find that theta. But it's going to have the same sign value, it's just going to be negative. So it is okay if you do this and just put a plus or minus on the end, but this is the better way to go because your plus or minus kind of comes out of the process. You don't have to remember to add it on later. Okay? Does that make sense? Any questions there? Okay, this idea here really leads into the next question we're going to look at, this number 3. Okay, and I kind of went over this with you on Friday, but it would probably be good for you to see again. So let's get our triangle PAM set up here. And I'm drawing this very, very not to scale, and I'm kind of doing that on purpose. So this is PAM. Angle P is 22 degrees. PA is 6. AM is 3, and I'm looking for this angle here. I'm trying to find that. Okay, talk to me about strategy here. What am I going to use for this problem? Yeah, so first of all, I can't use SOHCAHTOA, right, because it's not a right triangle, but I do have this convenient pairing, right? I have this like 22 degrees across from the 3. That tells me I can set up law of sines. So I'm going to say sine of 22 over 3 equals, and then my other fraction goes with the x and the 6. So I would say sine of x over 6. And then to solve this, I'm going to cross multiply. So I'm going to do the 6 times sine 22 and then divide by the 3. So 6 sine 22 divided by 3. And I get this. What is this that I just found? Is that x? What is it? It's sine of x. Yeah, it's this thing, right? So I found sine x. What are you going to tell me to do with it now? Yeah, so I have to do an inverse. So I'm going to do second sine of that decimal, okay? And I end up with 48.5 equals x. And that is totally accurate. Like, that is a correct answer, okay? It's just not all of the correct answer, okay? Because we run into another one of these problems here. As soon as I did this inverse sign here, my calculator gave me one of the answers. But there's two places that are going to have the same sign, just like we had two places that were going to have the same cosine. So when I do that inverse sign, so let's see, what do we have here? We have a sine of 0.749. Sine is on my y-axis, right? So 0.749 is going to be, I don't know, here-ish. Okay, if this is 1, then this could be 0.749. And so this would be one of my possible angles. And this is what I just found. This is the 48.5 degrees. But if I travel straight across my circle to the left here, this angle would have the exact same sign, right? Like if I was going to find the coordinates of this point, it would have a negative cosine, but I don't care about that. And it would have that same sine value of 0.749. Okay? So when I asked my calculator this question, my calculator isn't considering this possibility. How do we find what this angle is? How do we find the measure of this angle if we know this one is 48.5? Say it again, Ryan. One more time. Okay, so it's not necessarily going to be exactly double. This is going to look close to that because it's like 48.5 is really close to like the middle. But if it was more extreme, I think it would look like that. Ashley, what do you think?
Could you subtract 48.5 from 180?
Yeah, this is saying we're going 48.5 degrees this way. So this is going 48.5 degrees this way from 180. So I'm doing 180 and I'm subtracting 48.5. Okay. And so that's my second answer. So here I'm going to say or 180 minus 48.5. Okay, and I get this, we'll just call this 131.5. Mathematically, that angle would also work. So I could do this or I could do this. And so the problem I run into is like if I hit sine of 48.5 and sine of 131.5, they come out exactly the same. They came out a little off from that decimal that we had because we rounded them, but they come out the same as each other, right? And so when we set this up, either one of those angles would work here, okay? Which means that mathematically either one of those angles would be possible, okay? So it's okay if you don't have a firm grasp on this whole like, oh, there's two places that have the same measurement. That's, like I said, a bigger Algebra 2 topic. But as long as you know for this question, it's specific to law of sines. For this question, if you're asked to find like two possibilities, just subtract from 180. That's going to work for you every time. Just subtract. Get your one answer by doing inverse sine, and then subtract from 180. You don't have to worry about this with law of cosines. It's a problem that only happens with law of sines. And the reason for that is when you're working with cosines, the ones that match are like vertical from each other. They're up and down. And this bottom half of the circle will never make sense in a triangle because they're bigger than 180. So we don't have to worry about these angles. But these ones are okay. And so because law of sines gets hit twice up here, that's why we have to worry about it with law of sines. Does that make sense? Any questions there? Zoe? Nope. So when you do law of cosines, I guess the only place that would come up is when you take the square root for the a squared, right? But because that's a side length that you're looking for, you're never going to have a negative, so you don't have to worry about the plus or minus, okay? Okay, And then this last question, and I don't think I'll work all the way through this. I just want to make sure you understand what the directions are saying. These are some different properties, and some of them are legit properties that we learned about in lesson 10.3, and some of them are ones that I totally made up, okay? And your job is to figure out which ones are true and which ones are false, and then justify using either an example or a counterexample, okay? What's a counterexample? What do I mean when I ask you for a counterexample? Braden? Yeah, so plug in a number and show me that this is not true. There might be lots of things it's not true for. Pick one and prove it to me. Okay, so like this first question. This is saying that if I pick a random theta and I do the sine of that theta and the cosine of that theta, they're always going to be exactly the same. True or false? False. Okay, so what I'm going to do to prove it is I'm going to pick a theta, and I can pick anything. So I'm going to say false. Okay, and then I'm going to say, well, let's let theta be, sure, okay, theta is 1 degree, okay? So if I do sine of 1, that's equal to, it's going to be something real tiny, 0.017. And then if I do cosine of 1, it's going to be something real big, yep, 0.999, okay? And these two things are not equal to each other. This is what I mean when I say show me a counterexample, like plug some numbers in and show me that it's not true, okay? If it is true, I still want you to plug numbers in and just justify that it's true. So like, for example, I'll tell you this one. This is that Pythagorean identity we were talking about above. So just pick a theta and plug it in and show me like, hey, when I do this math, it equals 1, okay? You do have to watch out, and I'm being a little bit like real mathematicians would frown at me right now. Because if I want to justify that something's true, it's not really enough for me to just pick one example out of thin air and say, hey, look, it works for this one example. Technically, we should have to be like proving these things. That's not our mission right now, so that's why I'm not making you do it. But like this one, for example, I could find a theta that this is true for. But if it's not true for all of the thetas, then I can't say it's true. Okay? Like this would be true for 45 degrees. 45 degrees has the same sine and cosine, but no other angle has that. Okay? So that's your mission with those ones. Does anyone have specific questions about any of those? Connor?
Tangent of theta would be equal to cosine over sine, right?
Other way around. Sine over cosine. Yep. Yep. Tangent is sine divided by cosine. Okay? Okay. So for today, I would say your first mission is to make sure that that original test review you got, the stapled packet, that's kind of your primary test review. You want to make sure that's done and that you know how to do everything in there. These extra review problems should be done or close to it by now, okay, because we've done most of it together. And then I did print up an extra practice page on law of sines and cosines just so you could review that as well, okay? Now with this, I mean, it's up to you. If you feel like you're really, really good at this stuff, don't worry about doing this. I'll consider this technically to be optional, but this will be on your test tomorrow. So I strongly suggest you work through these, especially the word problems on the back, okay? So I'll give you this. You've got the rest of the time, about 20 minutes to work, and